Good evening, everyone.
Good evening. How are you today?
I am fine. I'm well, thank you.
All right, let us begin.
Professor, do you want to take questions now or after the class? I have some questions.
Depends on the type of question. Depends on the type of question. What question? If it's something
it's on the project that you gave to us.
That one I have to take it after the class.
Okay.
All right. So tonight, what we have tonight is hypothesis testing. Hopefully we finish it tonight. If you don't finish it tonight, then we'll finish it tomorrow. Now, I'll begin with what is common today that is always on the news, the COVID-19 vaccine. Before those vaccines we are used on people, they have been they have done some kind of clinical trials and tested it over and over before they can now make a conclusion that it is good for protecting the people from the virus, at least to some reasonable extent. So those testing, when they're doing those clinical trials, they do some tests, some kind of hypothesis test before they can now verify that or confirm that this vaccine is good for human consumption and for fighting COVID-19. So that's hypothesis testing is just like that. So and each time they do that kind of thing, they use statistics to analyze their data. So in other words, a statistical hypothesis is a type of a claim about a population parameter. So when we talk about population parameter, you're talking about things like mean and standard deviation, or even a proportion. So the claim may be true or not, can be true or false. But until you test the claim and verify that it's true, before that after that, then you can make an inference or conclusion. So you guys can see the screen, I believe. Am I right? Can you see my screen?
Yeah.
Yeah.
So what we do in hypothesis testing, we define the population and specify the parameter of study. But the parameter can be the population mean, it can be the mean, or the standard deviation can be mean, comma, or standard deviation. You have to specify what parameter you are testing. It can be proportion, P. For this class, we focus more only on the hypothesis testing for mean. Then you study the hypothesis that we investigated, give the significance level. I explained to you what the significance level is when we are doing a confidence interval. The alpha is the significance level. Alpha, use the symbol to present the significance level. So if you say alpha is let's say 0.05, you mean that your chance of being wrong is 5%. So that means, or if you say alpha is 0.05, for example, if you say alpha is 0.05, yeah, or 0.01, that means that let's say 0.1, that means your chance of being wrong is 10%, and so on and so forth. Then after that, you can now select the sample for the population, then collect your data, analyze the data, then perform the calculations for the tests, and then reach a conclusion. That's all we do in hypothesis testing. So some of the questions we answer, like, does a particular medication lower blood pressures? Does seatbelt reduce severity of injuries in an accident? Does the COVID-19 vaccine, is it effective for fighting the virus? Does public custom, all kind of questions. That question now, once you add that question then you now state your hypothesis. Define the population and the parameter, then state your hypothesis, put your significance level, then select the sample, collect data, analyze, and reach a conclusion. Now, there are two hypotheses we use. the null hypothesis, which is a statement that the true value of the parameter is such as the mean is equal to some claim value. So that means for the null hypothesis, we often use this symbol for null hypothesis. This symbol, like, some kind of equality. Like we can use equal sign, okay, or greater than or equal to. For null hypothesis, greater than or equal to. Or you can use less than or equal to. Okay. You can never use only less than or greater than in the null hypothesis. You can only use any some kind of equality symbol. Okay, because it tells us that it's equal to some specified value. But for alternative hypothesis, says the opposite of the null hypothesis. And for alternative hypothesis, the symbol we use most of the time include not equal to, greater than, or less than. You can never use this symbol for the null hypothesis. You can only use them for alternative. And the symbol that you use for null hypothesis, you cannot use for alternative. You cannot use these symbols here for alternative hypothesis. When we start splitting the hypothesis, it will be more clear. Now, of course, we are human beings. Not only human, even machine commit error. So there are type of error we commit when we do hypothesis testing. The type 1 error, this one occurs if you reject a true null hypothesis. So when it is true and we reject it, we have committed type 1 error. So the probability of that committing type 1 error is what is called the alpha. That is the significance level. Okay. Now, next one is type 2 error. In this case, we reject null hypothesis. Sorry, we do not reject null hypothesis when it is false. It is false, and yet we do not reject it. In that case, we have committed type 2 error. So we can represent this with matrix. They say HO true, HO false. Now, if HO is true and we reject HO, that is, it is true, yet we rejected it, we have committed type 1 error. But when it is false and we rejected it, we have made a correct decision. Now, when HO is true and we do not reject it, we made a correct decision. If it is false, yet we did not reject it, we have committed type 2 error. So we made this kind of error in our daily lives sometimes. But one thing that if the probability of committing them is very small, then we can live with that. When it is high, that's when we get into trouble. I'll explain this with many scenarios I can use, but my favorite one is the one that's the jury trial, hypothesis testing. In the jury trial by the jury, there are 4 possibilities. Defendant is guilty. The defendant is innocent. The defendant is convicted. The defendant is acquitted. Now, the decision of the jury does not prove that the defendant did it or not. The decision of the jury is based on the weight of the evidence presented. So I'm sure you must have listened to the news. Some people who were convicted stay in the prison for 30 years, only for them to realize through DNA test that the person was innocent and they were released. So that can happen. If the weight of evidence is so high, even though the person didn't commit it, the crime, it might still be the jury will convict him or her. The same thing. If the weight of evidence, even though they know the person has committed the crime, but there's not enough evidence to prove it, they can still let him go. So let me explain it with this hypothesis testing. Usually, HO will now become, okay, our HO will not happen to be the defendant is innocent. Okay, that's our HO. and H1, okay, will be the defendant is guilty. Okay, so this will become our hypothesis. Now, of course, whatever they call them, I think they call them the state attorney. I think that's what they call them, state attorney or the prosecutor. We present the evidence to the court, and this is the possible result. Okay. Now, defendant HO true means that defendant is innocent. And HO false is that he or she is guilty. Reject HO means to convict the defendant. Do not reject HO means to acquit the defendant. Now, if the defendant is innocent, but there's not enough evidence to prove that he or she is innocent, that means he become convicted. The court has committed type 1 error. Now, if the defendant is guilty, but there's enough evidence to convict and he was convicted, then the court have made a correct decision. See? Now, if the defendant is innocent and there's enough evidence to acquit him or her so that he was acquitted, the court have made a correct decision. And if the same defendant is guilty and he or she was acquitted because there's not enough evidence, then the court have committed type 2 error. Questions? Any questions so far? What I have explained?
Please, can you re-explain?
Now, the hypothesis is this. HO is the null hypothesis is that the defendant is innocent. H1, the defendant is guilty. And HO means that he's innocent. HO true means that he's innocent. HO false means that he's guilty. Now, in a hypothesis testing, you either reject HO or you don't reject HO. Now, if HO is rejected, it means that the defendant is convicted. So if he's innocent and HO is rejected, that means he's convicted, even though he's innocent. Then the court have committed type 1 error. Or the jury have committed type 1 error. Now, if he's guilty and there's enough evidence for the jury to convict him, then the jury have made a correct decision. Now, if the defendant is innocent and there's enough evidence to prove that he's innocent, that means they do not reject HO. That means he's acquitted. Then they have they made a correct decision. And if the defendant is guilty, but there's not enough evidence for the jury to convict the defendant, and since that means that he was acquitted, which means the null hypothesis is not rejected, then they have committed type 2 error. Okay, well, any other question? Excellent.
Where do we get, I have a question. Where do we get the information from to determine if he's innocent or guilty, or is this just a hypothetical situation?
Well, of course, if you go to the court, you see that there are witness statements, the camera that shows what happened and where the crime was committed. So witness statements or sometimes the anonymous call to the police that they saw so and so. All those are the evidence that the prosecutor will present. There are so many ways they can bring evidence to the court. These days they have cameras to show a lot of things. So if there's so many other things that they'll ask the prosecutor will ask the defendant so many questions. Where were you so and so time of the day? Where were you this day? You have been to the court before, right? Mr. It's more.
Yeah,
So you know what I'm
Yeah.
talking about then, right?
right.
So if that evidence is not enough to convince the jury, in any case at all, it's not only in criminal case, in any case at all, in that case. So you can see the hypothesis testing taking place. Now it can take place. Go ahead.
No, I was saying, oh, okay.
It can take place in any even in impersonation, in police pulling a driver. So you can use this example to explore, try and practice this kind of scenario, because I'm gonna ask this kind of question in the exam. So I recommend that you practice some of this by yourself, following this method I use here. You get used to it, and it's really very interesting. So I did this one, and then I left these two open for you guys as a practice. Now, this leads us to how to state hypothesis. You remember that I mentioned that we'll be focusing on only on hypothesis testing for the mean. So, and you also remember that I said that for null hypothesis, you can only use these symbols: equal, greater than or equal to, less than or equal to. You can never use not equal to here when the null hypothesis. You can never use only this symbol like this one. You can never use it here. And you can use less than in null hypothesis. Now, in alternative hypothesis, you can only use this symbol here. You cannot use equal to in the alternative hypothesis. And you cannot use greater than or equal to symbol here. And both hypotheses are saying the opposite of each other. When one of them say this, the other one say the opposite. Yeah, counter it. So let's see. That in mind, let's see how to state hypothesis. The first one is this. The question says, state the null and alternative hypothesis for each conjecture. I'm going to move it down so that we have enough room. It says here, a researcher thinks that if expectant mothers use vitamins, birth weight of the babies will increase. See, look at this, we increase. That's the keyword right there. Increase means greater than. Greater. So now, prior to that, the average birth weight of the population is 8.6 pounds. So now, average, of course, is mean. Average mean. So hypothesis solution, null hypothesis H, we need two of them, HO and H1. I'll show you the two methods because some books use one method. So method one, and use which one method you prefer. Method one, HO and H1. And I say H1. Now, HO, that means mean, said he thinks that the birth weight will increase. We increase means greater than, and you can only use greater than symbol in the H1. So you state that one first, because you can only use we increase, which is the greater than symbol in H1. So H1, that means mean, greater than 8.6 pounds, because this is the average 8.6 pounds, which is what he's claiming. Because he thinks that they will increase. That's his claim. Now, so the HO says the opposite of this. So you gotta be less than. Because what this one said greater than. So this one H will be less than that. But you cannot use less than symbol here. You can only use less than or equal to. So that means that H1 will now become mean is less than or equal to 8.6 pounds. 8.6 pounds. See, that's it. You have stated the hypothesis. So this is for method one. Some books will ask you to use, some books want you to use equal sign for all null hypothesis, which is in this form. You will look in this form. Method two. You just to change this to equal sign. That's all. So both of them are correct. Them are correct. Now,
Excuse me, Professor.
mhm.
So if you're giving us we are doing a test now or an exam, we can use any method.
For this one, for this class, use this because it's more direct. This tells you that this is say the opposite of that. Okay. Now, this one comes from the fact that null hypothesis. If you look at the definition of null hypothesis here, the null hypothesis is a statement that the value of a population parameter equals to some given value. So that's where the equal sign comes from. So, but the question from the question, you can now
When it's saying plug in, when it's saying it's full.
use this one. But I showed you this one because some books use that because of that equals that word equal. I recommend you use this one. So we'll be using this one. Okay. Any other question?
So both examples in method 1 we can use, or you just both examples in method 1 we can use, or not, and not just the first line, right?
Yeah, always use method 1. I will show you. Method 1 come in different form. I will show you. We do more. We do more examples so you can see. But method 2, they tell you to use equal sign in all the null hypotheses. But for method 1, it changes depending on the way the equation is framed. And that's the one I prefer because it's more accurate to me. So let's do another one. It says, an engineer claimed that the mean number of defects can be decreased. See, can be decreased is the keyword here. Decrease means less than. So the minimum number of defects can be decreased in manufacturing process for compact disk by using robots instead of human beings for certain tasks. The mean number of defective disks per 1,000 is 18. So HO H1. Now, I say that he claims that the mean number of defects can be decreased. That means decrease, and you can only use decrease here in an alternative hypothesis. So that means it's going to be mean is less than 18. And that is his claim. Yeah. Now, they not always say the opposite of the alternative, which is that the mean, mean is, so you gotta be the opposite. I mean, this one is decreased, then this one should be increased. But you cannot use greater than symbol here. You can only use greater than. Greater than. Can you mute yourself, please? Oh, can you mute yourself? Oh. Can you mute yourself, please? Can you mute yourself? Let's see. Now, any question on this one? I can see that.
Please, can you explain again, please?
That mean is that can say that the mean number of defects can be decreased. So that means mean less than 18 claim, since you can only use less than in the alternative. Then this one says the null say the opposite of that, which means that it can be increased. But since you cannot use the greater than symbol here, in that case,
HO is the symbol for null, and H1 is the symbol for alternative.
Look at this. It said here, a psychologist feel that playing soft music during a test will change the result of the test. Change the result. It didn't say increase or decrease, but say it will change the result. The psychologist is not sure whether the grade will be greater or lower. He wasn't sure which direction. Just in the past, the mean score was 73. So in this case, he wasn't sure. All he knew that it will change. So HO here and H1. Okay. We have that H for say we change we change the result. He doesn't know whether it will change it to left or to right, whether it will decrease or decrease. So all we know that he will change. That means not equal to, which you can only use in the alternative hypothesis. So you have mean is not equal to 73. The claim. Okay. Then H1 will now becomes the opposite. Not equal to means equal to. So mean is equal. Let me see. How would I say the equal sign? Equal sign. Okay, equal. Let me get it from here. Equal 3. So claim is not always in the alternative. Claim can also be in the null. Let me see if I have an example like that. This one, the one that have percent are for proportion. So we're not doing proportion. So we're not gonna be doing
Professor,
this.
can you please let me see the question for the psychologist?
It's right here.
Okay.
All right. Now let's do what one is that like I say, this one's that half percent are for proportion. Since we are not doing the hypothesis for proportion in this semester, so we're only looking at the mean. The one that have the mean. So let's try this one here. It says the average income of accountant is 51,497. See, is means equal. So we have HO and H1. Say is, and is can only be used in the null hypothesis. So that we have mean equals 51,497. That was the claim. Okay, claim. Now, the null hypothesis alternative will be the opposite of that. The opposite. It means mean. Okay, mean is not equal to 51,497. So that's how you state hypothesis for the mean. This one you can practice, use as a practice. Yeah. Now, any question before I move on to the next thing? Okay, good. Now, here are some terms we use in hypothesis testing. Significance level. We use the alpha to represent it. Like I said earlier, it is the probability of committing type 1 error. We have come across this before when we are doing confidence interval. When I tell you that we have 95% confidence level, 90% confidence level, and 99% confidence level. So if you're 90% confident, that means your significance level is alpha. We have 10 minutes now, which is alpha is 10%. Your chance of being wrong. Now, if you're 99% confidence, your chance of being wrong is 1%, which means that your alpha is 0.01. So you can see here, this person is, so for example, a significance level of 0.05 or 95% indicate 5% risk. See? Now, critical region is what we call the rejection region. And it goes, it tells you if your answer falls or the test result fall in that region, you reject it. Don't worry, you will see how it is identified In a few minutes, I'll explain more. Now, the critical value is like the cutoff value, the value that cut off and cut off the critical region from non-critical region. Yeah. Now, I will use this diagrams here to explain it. Let's start it. For the type of test we have 2 tail tests and 1 tail test. The diagram might illustrate it. This is 2 tail tests. It goes this way. I use a diagram. It goes like this. I think I failed it. Let me try it again. Do this. All right. So I got it. Now, and we have this symbol here, and we have this. Remember this diagram, this center line. Okay. So now, usually on the left side we have 2 lines. Left tail and the right tail. Okay. Now, for the left tail, let's say I use this. You can see that it is. I'll have to paint with this. See the whole of this and the whole of that. So if your answer fall in any of this, okay. Okay. I think I picked, let me see, give me 1 minute, let me put it back. Okay. Okay. I think I'm gonna use a better diagram to make this. Home. In 1 minute. Home. Right, let me go and pick something else. It's better. Just 1 minute. I'm trying to figure this out. I pick this. Okay, put it back. So we cover this. This is the shed this side. We can finish the shed. Okay. Use this. Okay, on this side. All right. So you can see that it has 2 tails. So we call this okay, it's on the I think I'm gonna move this down so that we can have enough room. Let me move it down so we can have enough room. Okay, good. You can see that it has 2 tails, the left tail and the right tail. So the left tail here has Z alpha over 2 alpha over 2 here Z alpha over 2 because it has 2 tails over 2. So I'm gonna make it put it the right way. Then this one alpha over 2 And this one, because this one is on the left side, it's negative. This on the right side is positive. So here is the critical region here. The critical region. Critical region. And it is right here. This is the critical region. If your answer fall in this critical region, or you can call it rejection region. Yeah, answer falls here or on this side. This is also a critical region. On the left side, here is also a critical region. So on the left side, I think I didn't do it well. So if your answer falls in any of this region, left side or right side, you reject. But inside here is the acceptance region. If your answer fall within this side, you accept. But if you fall in any of these regions that are shaded, you reject. So we call it the critical regions. This line here is for Z alpha over 2. And this line here is for negative Z alpha. So this line is a critical value. If your answer fall on the critical value or any of these shaded parts or any of the shaded parts, you reject. Now, because it have two of them, you have one on the left side and one on the right side. We call it a two-tailed test. And this is how to say hypothesis for a two. How do you know if you are stating hypothesis that it will be a two-tailed test? If you use equal to and not equal to, like here, if you look at this one, we use the symbol equal to, because it can be left or right. And not equal. This means that this is a two-tailed test. Two-tailed. Now, if it is if you look at it, there's another example that is a two-tailed test. The one that for the psychologists. Yeah, this is another one. See? Because you have equal and not equal. So you call it a two-tailed test. Tailed test. So, and again, we call them a two-tailed test because they have two tails, the left tail and the right tail. Questions before we are timed out? Any question? Excellent. Now we'll come back. I will show you how a one-tailed test will look like. And then please, we have less than 1 minute now. So I'm gonna to save time. I'm going to time us out. Log back here after 10 minutes. Okay? Can you hear me? Hello.
Yes.
Yes.
All right, I'll see you guys in 10 minutes then. Let's see.